Smart contracts on Solana move billions of dollars. When they have bugs, the losses are permanent. There is no undo button. The common approach to finding these bugs is through security audits, usually done by auditors and security companies. And this process is usually um, takes a long time, and it's also available to well-funded teams. This means that um, early startups cannot afford security audits at their early stage. So I've built Invariant-Gen to help anyone to formally verify their smart contract. Invariant-Gen is a command line tool that automatically generates formal security invariants for Solana Anchor program specifically. You give it your program source code and it gives you a set of formal properties that describes what your program must always do correctly. And you can verify these properties with tools like KetGen or Canny. Here's what makes it different from just asking an LLM to review your code. It does not guess. Invariant-Gen has a knowledge base that is built from real professional security audits. The same findings that Halborn and other top firms have identified in production Solana programs. Every invariant it generates is grounded in real vulnerabilities that real auditors have found in real programs. And everything runs, you can either run Invariant-Gen locally using um, QVAC, or you can decide to use the Anthropic model. Next, I'm going to be talking about the architecture. Thank you. So here I'm going to be walking you through the architecture. The system has two separate pipelines. First is the on the left we have the knowledge base pipeline, and on the right we have the generation pipeline. And in the middle we have our keyback local server. So starting with the knowledge base pipeline, we take professional PDF audit reports from companies like Halborn, Zelich, and so on, and then we run them through our extraction step, which now converts these audit reports into structured JSON files. And these JSON files are embedded using our GTE large embedding model, which converts each finding into a 1024 dimensional vector, and it returns a knowledge base.json. So you only need to run this build knowledge base command once to get this knowledge base.json file. And on the right here, so for the generation pipeline on the right, we point the CLI to our anchor program source code, which should be an LLM.txt file you can generate from git ingest. And the CLI passes out every instruction handler. For each handler, it sends an embedding request to keyback, the same GT module we have here, and we get a vector representation of that handler's code and context. So that vector can be used to search the knowledge base for the most semantically similar audit findings. So let me walk through the core commands of this demo, which um, we demonstrated. First, we have build KB, and this is where it all starts. We feed our reviewed audit reports into the knowledge base, and then we turn them, we convert them into JSON files. Second, we have the info command for showing knowledge base statistics. Third, we have the search command for searching the knowledge base directly. So you can search the knowledge base before generating anything. And lastly, we have the generate command for generating formal invariants for your Anchor program. This is the main command. So here I'll be talking about building the knowledge base. The first thing the Invariant-Gen needs before it can generate anything is a knowledge base, and this knowledge base is what makes the tool smart. So instead of asking the LLM to guess what security properties the Solana program should have, we retrieve relevant examples from a real audit report first. So these audit reports are extracted, and each audit report is stored as a JSON file in the knowledge base directory, and each file represents one audit report. So these JSON files are extracted and used to build the knowledge base. The audit reports we are using here to demonstrate this demo is the Halborn Goose FX swap and Halborn clone protocol audit reports. So you can see here we did cargo run release build KB, cargo run release dash dash build KB. So and here are LLM built the knowledge base, and literally here I'm just showing the results of the knowledge base that we just built. The model which we use to build the knowledge base is the GTE large model, and let me just show you in the audit terminal. So yeah, this is where the knowledge base is sorry, this is where the LLM is running, and you can see here this is where we're running GTE large LLM, and you can see here that we made a post request to the /embeddings endpoint, and it returned a status code of 200, which means that building the knowledge base was actually successful. It was a successful request, and yeah. So here I ran the info command to show us to show you the stats of our program, and here here I ran the info command, providers keyback, server is responding perfectly, um server is responding perfectly. So how do we know that server is responding? We made a request, we made a get request to v1 slash models, and it returned a status code of 200 to show that it's actually working. And this is the knowledge base that we just built, where we have this info, and these are the configurations in the file located. Yeah, I'm demonstrating the search command to prove that the knowledge base is working. So the query is missing signer check on authority account, and these are the results. Goof FX swap update vconfig. The base config instruction must verify that the full authority account has signed the transaction before modifying any fee configuration state. So we have 5 results for this particular search. We have 5 results for this particular query. We have from GoofFX and Clone Protocol, which we are using for demonstration. And if we check our running server, we can see that we have a push request that was made to v1 slash embeddings endpoint, and this is the configuration for my server which I used to demonstrate three commands: search, build knowledge base, and the info command. So this is the main command to generate an invariant for your program, for your entire program, or for your instruction. So here we run this command to generate an invariant for this program swap.llms.txt. So and we want to generate an invariant for um, this particular instruction, the create AMM instruction that we saw in the Solana program. So here we run this command, and then our LLM processes the request. um, we have two requests. We have one to slash embeddings. Let me show you the second terminal. Yes, so we have this request to slash embeddings, which was successful, and we have the second request to slash completions. So this is the output. This is simply just the debug output uh, from our command, and that will be the end of this demo. You can test it out by cloning the repo.